Hello everyone, let's solve some Leetcode today. So today we have this Leetcode 506 problem, that is relative ranks. In this problem, we are given an integer array score with size n. Now here, score of ith index is basically the score of the ith athlete. So in this case, we are using the integer or basically a number to represent any particular athlete. Now all the scores are guaranteed to be unique. It means that there will be no duplicates in the array, which makes things easier for us, I believe. Now the athletes are placed based on their scores. So placed means, I believe, ranks, where the first place or first rank athlete has the highest score, which makes sense. Then the second place or second rank athlete has the second highest score, and so on. The placement of each athlete determines their rank, which basically means that placement and rank are basically same at this point. Now there is some additional information here. The first place athlete rank is gold medal. So what they are saying is that the first rank is actually having a special name called gold medal. The second rank also have a special name called silver medal, and the third rank also have a special name called bronze medal. For the fourth place to the nth place athlete, their rank is the placement number itself. So the X place athlete will have X rank. What they are saying is that after fourth rank or fourth place, there is no special name or particular name given to those ranks. The fourth rank or fourth place is simply 4. The sixth rank is simply 6. The seventh rank is simply 7. There are no special names associated with those ranks. Now we have to return something. So return an array answer of size n where answer I is the rank of ith athlete. So basically what we have been given is a score array where each ith index of this array actually represents the score of the ith athlete, and then we have to return an answer array in which the each index will represent the rank of that ith athlete. Now let us try to understand it with the help of an example here. Here we have a score array with different scores. We have 10, 3, 8, 9 and 4. So basically these are scores of ith athlete. So we have 0th athlete, first athlete, second athlete, third athlete and then fourth athlete. Basically we are using these indexes in place of names for the athletes. Now what we have to return is an answer array that will be equal to the size of this particular score array, and in the answer array each element will be the rank of that ith particular athlete. For example, the rank of the 0th player should be gold medal because it is having the highest score in all of this place. So it means that I must write gold medal. In the same way, the first element, what is the rank of this one? Because it is having a 3 score, so is it the second highest? Nope. The second highest is this. Is this the third highest? Nope. The third highest is this. Fourth highest? Nope. Fourth highest is this. Fifth highest? Yeah. So the rank of this one is 5. So for the fifth rank, there is no special name, so I will simply write 5 here. In the similar way, 8 is what? 8 is the third highest, right? And the third highest have a name called bronze medal. So we will simply write bronze medal here. In the same way, what is 9? 9 is the second highest person, right? 9 is the second highest score. So this particular player, the player of index 3, will have silver medal as rank name. Now, in the same way, what is 4? The 4 is basically the fourth highest score, and it is also coincidentally at the fourth index, right? So, after this silver medal, we will simply write 4. That is the rank of the fourth index, okay? Because this is actually the fourth highest, so the fourth rank actually does not have any special name. So, we will simply write 4. And this is basically the answer. So, at each index, we are basically writing their rank at this point. So the 0th athlete had a maximum score, so it is going to get gold medal. The first athlete was actually the fifth person or the fifth ranked person. So we have written 5 here. Similarly, the second athlete here was having 8 as a score, which is the second or the third highest actually. So we will write bronze for this person. Its rank is bronze. In the same way, the third element actually had 9 as a score, which is the second highest. So we will simply write silver medal for its rank here. The fourth element, which actually have score as 4, which is a coincidence, actually is the fourth highest score. So basically their rank is 4. So I have written 4 directly here because it does not have any special name. And that's about it. Basically, that's what you really have to return in this one. So there are a couple of ways to solve this problem. One of them is sorting. So what you can do is you can actually create another array, and that array will contain tuples. So we will have the score and its index. Okay, so 10 have an index of 0. Then we will have The next element, that is 3. 3 have an index of 1, correct? Then we have 8 at index 2. Then we have 9 at index 3. Then we have 4 at index 4. Now we have an array where we are storing the score as well as the index or the position of that score. Okay. Now what we will do is we can go ahead and sort this particular array. Okay. Once we sort this array, what will happen is that we will sort based on the first element of each tuple. So 10, 3, 8, 9, 2. These will be used for sorting. So this particular array after sorting will become something like this. Okay, so as you can see that after sorting, what we have are ranks. So we have basically sorted based on the score, and so we have ranks. So zero athlete is at this zeroth position, right? So it is the first person, or the place or the rank is first, because the 0 plus 1 is 1, right? So since the arrays are 0 based indexed, so we will simply write I plus 1 for rank. Okay, for rank we have I plus 1. In the similar way, this particular place or this particular athlete will actually have an in rank of 2, right? Because the index is 1, so the rank is second. So it will be a silver medal. Similarly, this will have a rank of basically 3, because the index is 2 in the array, so the rank is definitely 3. So it will be basically a bronze medal. Here we will have a rank of 4 because the index is 3 here. So the fourth rank means 4, right? And similarly, we will have 5 here because the index is 4, so we will have a rank of 5 here. Now, based on this data, what you can do is you can create an array, okay? And here you can actually fill this array already with empty strings everywhere. Okay, so you will create an array of size equal to the score array, and you will fill it with empty strings. And then you will iterate over this particular array, okay? This one. Then you will see, okay, the first element have is a tuple, and in that tuple place is actually 0. And since it is the first element in this particular array, it means the rank should be 1, okay, or the first. And so at this 0th position in the answer array, you will write gold medal. I'm just writing it in a short way here. So we have gold medal here. Now we will move on to the next element in this particular array, that is 9, 3. So here we can see that this particular athlete, the 3 athlete, is actually having a silver medal rank or the second rank. So we will go to this particular index in our answer array. So we have 0, 1, 2, and 3. And so at this particular index, we will write silver medal. And then we will move on. We will see 8, 2. The rank is basically third because the index is 2. So rank is going to be 2 plus 1, 3. And this particular athlete is actually at index 2, right? So we will go here in our answer array, we will search for the index 2, and here we will simply write bronze medal. Okay, now we will go back here. In this array, we will have a 4, 4, which is at index 3. So the rank is definitely 4, 3 plus 1, 4. Rank is 4, and this particular athlete is actually fourth. Okay, so in our answer index, we will go to the fourth index, this one, and we will write here 4 because fourth rank does not have any special name, so we will simply write 4. Basically, at first position in our answer array, we will write fifth rank. So this particular person had fifth rank. All of this is array. Okay, all of these are basically strings. So this is one way of doing it. Now the time complexity for a solution is n log n, and the space complexity is order of n. Now there is one more solution for this problem, but that will not actually make the time complexity better. It will make the implementation of the solution better. We can actually use heap data structure, particularly max heap data structure. So the max heap data structure is basically a data structure in which once you add a few elements, like just say any elements, 1, 2, 3 or something like this, then it will give you the maximum elements from this set of elements. So once you pop anything from this element, the maximum will be given first. So third will be given first. Then if you pop again, then second. Then you pop again, then this one, right? So the maximum element will be given first to you each time you pop. And in the earlier solution, the reason we had to sort the array is just to make sure that these scores, the 10, 9, 8, 4, they actually just get into an order, okay, from maximum to the minimum. That's the only reason we had to sort this thing, right? So the same thing can be done with the help of max heap. Yes, it will not sort the array, definitely, but it will actually simulate the same behavior. Each time you pop from the max heap, the maximum element present in that heap currently will be sent to you. So this one will be sent first, the 10 comma 0, then 9 comma 0 will be sent to you. After that 8 comma 2, after that 4 comma 4, after that 3 comma 1. So you will be getting elements in the order of their ranks in a max heap because of the scores. So what we will be doing is that we will having a max heap, and then we will be iterating over the score array. So for I in 0 to n minus 1, or basically, yeah, n minus 1, what we will do is we will actually add tuple. Okay, so we will have score, or basically we will have element is equals to a tuple of the score. So we will have score and comma I. So we will add this particular thing into our heap. So heap, and in the mh, that is maximum heap, and then we will put element. So this is how we will actually basically populate our heap, and after that we will simply iterate over the heap. We will go ahead and say 0 to n. Now we are iterating over the heap. Okay, first we will actually pop the heap. So we have popped the element from the heap, and this element will be actually having the maximum score currently available in the heap. So we will take its index wherever this thing actually was in the score array. So index is going to be lm, because we actually have this, okay, in the tuple. So score is on 0th and I is on first place. So we are taking first place. And now after that, what we can do is we know that the rank is going to be this one, right? Since we are iterating from 0 to n, so rank is going to be I plus 1. Okay. And then we can simply assign this rank to this particular index in the new array. Okay. So we will actually have a new array having some value. We will initialize it for n values. And then what we will do is we will say answer array at this particular index will have a rank, this one. Okay, and that will actually solve your problem. Now the question is, what about the special names for the ranks? So first, second, and third have special names, right? Gold medal, we have silver medal, and then we have a bronze medal. Now that can easily be handled with the help of a hash map. So in the hash map, you will simply store 1 to gold medal, then 2 to silver medal, and then 3 to basically bronze medal. Okay, so you will have a hash map, and then in our code I can put a check here that if rank in the hash map, then we will say answer index is equals to hash map rank, and that will give you proper string for that particular index, right? And this condition will only be true for 1, 2, and 3 position, because there is only 1, 2, and 3 in the hash map. So this is how you can actually solve this question with the help of sorting as well as heap data structure. So here is our solution. We have a data array first of all, and in this data array we will actually create the heap. So I have imported the heap queue module that will help us create a heap. Then for each element in the score, what I'm doing is that I'm creating a tuple of a minus score of I comma I, and then I'm pushing it into this particular data heap with the help of heap q dot heap push function. Okay, so this will push the data in the this particular array, and then also convert this array into a heap at each insertion. Now you might actually ask, why am I using the negative sign? The scores should be positive, right? And the reason is that in Python, you don't actually have a max heap implementation. You only have a min heap. So if you want to create a max heap, what you have to do is you just have to negate the elements. Okay. So that will automatically create a max heap. And then when you're accessing these particular elements, you can just make sure to just multiply them with -1 again to get the original number. After that, we have a particular hash map, and this hash map actually contains the strings for these particular ranks. So for first rank, we have a string for gold medal. For second rank, we have a string for silver medal. And for third rank, we have a string for bronze medal. This will be handy later on. Now, what we are doing is we are iterating over the length of the score. Understand that we are not iterating over the score array. We are iterating over the length of score array, okay? Because the length of heap and length of score array will be same. Then what we are doing is we are taking the scores and the place from this particular tuple. So each time we pop the data from this data heap, we will get a tuple, right? And in that tuple, the first element will be score and the second will be place, right? So that's what we are doing here. We are just taking out these two in a two separate variables. After that, what we will do is we will check if the current rank, okay, so this I is going to be the rank. So if the current rank is in the medal map hash map, what we will do is we will simply take this particular place, the index of the ith athlete, and we will simply say score at place is equals to medal map at I plus 1. So why am I using the score array here? Why am I not creating a new array? And that is because in Python you have this flexibility to actually add different data types in the same array. So what I'm doing is that I'm simply taking the score array and basically over-adding the value that each place in the score array. So yes, in other languages like C Sharp, you will actually have to create a new array, but you get this kind of flexibility in Python. So I'm just using the same score array, updating it, and then just returning it at the end. Now, in case this particular rank is not in the medal map, all you have to do is just place that particular rank in the this place in score, and then that will be the answer. So after this entire for loop, we are simply returning the score, and then that will be our answer. And as we can see that the solution is taking 11 milliseconds, the time complexity for this solution is still order of n log n, because yes, the heap push operation is log n, but we are pushing n times, okay, so it becomes n log n. In the same way, taking out an element from a heap is log n, but we are doing it for n times, so it becomes n log n. And the space complexity is also order of n because we are creating this data heap, and the size of this data heap will be as much as this score array size. Space complexity is also order of n because we are creating this data heap, and the size of this data heap is going to be same as the score array list. So yeah, if you have some question that you would like me to target, then just let me know in the comments. Bye.